First, to show that f and g are inverses, we need to use our inverse function property, which states that the composition of a function with its inverse should be the identity function. In other words, it should equal x after you plug one function into the other. So we need to look at two combinations, okay, two compositions. F of g of x we need to look at, and we need to look at g of f of x. And both of them should end up being x. So first for f of g of x is x squared plus 3 over 2. And now we apply f to that input. So f is the square root of 2 times the input, and then minus 3. And now we can simplify this. Okay, the 2's cancel there, and we have the square root of x squared plus 3, and then minus 3. And then we can go ahead and cancel the plus 3 and the minus 3, and we've got just the square root of the x squared. Okay, now when we're simplifying this, it's important to recognize that we're working within the domain of what we just plugged in, and what we're kind of looking at here. I'm going to go ahead and just finish this off, and then we'll talk about the whole domain and range thing here. The square root of our x squared, the square root and r squared will cancel, and that will give us x. Now we go over here to g of f of x, okay, and well, f of x is the square root of 2x minus 3, and now we can go ahead and apply g to that input. So we take that input and we square it, so 2x, square root of 2x minus 3, squared, plus 3 over 2. And we simplify. Well, the square of a square root is just that inside, so 2x minus 3 plus 3 over 2. Okay, now those minus 3 and the plus 3 cancel, and we have 2x over 2. And of course, those cancel as well, and we just get back our x. Okay, so both of these functions, both of these compositions give us back x, and that's the verifying that our two functions are inverses. Now, the domain and range for these are very important because they are really only inverses as long as we match up those domain of one to the range of the other, and vice versa. So, well, f we can see has a specific domain. The domain of f. Well, the thing underneath the square root, 2x minus 3, that has to be greater than or equal to 0. Now we add 3 to both sides. 2x has to be greater than or equal to 3. And then divide both sides by 2 and get x has to be greater than or equal to 3 halves. Okay, so now that's our domain of f. That means that's also our range of g. Okay, so our domain of f, we can write in interval notation, is 3 halves to infinity, and it's also the range of g. Okay, they're both of that thing. Let's go ahead and move this over and put that. Okay, that's for both of those. Okay, then we can do our domain of g and the range of f. And this is where we need to be super careful, because looking just at g, it looks like we could plug anything we want into that, all right? But the range of f is not actually anything. Okay, this is going to be, well, this square root function, it's got some horizontal transformations. We've got the shift to the right of 3 units, and the horizontal compression by shrink by a factor of 1/2. And that's going to give us something that I'm just going to do a quick sketch here. We'd have something that looks like this, okay? Which of course has a range of 0 to infinity. So that's the range of f. 0 to infinity, which means that has to be the domain of G that we use. Okay? Even though if you just look at G, you could of course plug anything you want into this. But only when G has a domain of 0 to infinity are it and F actually inverses of each other. Okay? Now that domain on G is actually the key that makes this square root of x squared work. Because sometimes the square root of x squared might not, it's actually the absolute value of x is what it is, and if x is negative, then, it doesn't just give you back x. Okay, so it's important that, especially with like square roots, it happens a lot with like even roots, where the inverses, you need to make sure that there's some type of restriction on the domain so that it all matches